Hi, my name is Jason Norton. Thank you for letting me come and talk to you today and interview for your company. One of the challenges that I've experienced recently that I had to overcome was during a project um, in which we were dealing with legacy code. And so I was delivered a legacy code base that primarily focused on the front end. There was a small implementation of the back end, but it was limited. And what my task was to grow or expand the back end to be able to handle certain constraints. And namely, those constraints were a database that had 10 million entries in it and could handle 10,000 requests per second. So a load test and also kind of dealing with like a database of that size. So even though there was this front end component already built, how do you deal with the concept of big data? And I think that's a really important and interesting question and challenge nowadays as we look at some of these companies. And basically, as companies continue to grow, whether you are part of the big or you are, medium, small to medium, eventually companies are going to be dealing with more and more data as we move forward. So in this, we had about 3 to 4 weeks to build it. We're halfway done right now. And the initial phase was really to compare databases. So a NoSQL and an SQL database. In this case, my project, I looked at Mongo and I looked at Postgres to kind of compare those two. It was my hypothesis that SQL would be faster. I've often heard that Postgres is used at enterprise level. And so that's what I went in assuming, but of course wanted to test both sides. So when we first started, when I first started this kind of project, or once I had decided what my hypothesis was, there was this idea of like, how do you actually make 10 million data points? That's extremely difficult, and or at least at the time it was. And so three options really. We could do some kind of API call to a front end system or to a back end system, but to some kind of other company and try to pull data. That wasn't really realistic because they would eventually block our IP address, and you're talking about a lot of time kind of network calls being spent trying to grab data. The next was kind of looking at a small handful of like real data and then just duplicating that. But that's not really going to test a lot, and it doesn't emulate the real world very well at all. So then the last was to focus on the shape of the data. What does the data look like? Sentences, text, numbers, arrays, and to look at that shape of the data and then to kind of fake it. And I use that word because the library that we eventually use is called Faker. And it basically just puts in stub data that emulates the shape. So once we figured out, okay, so this is how we can build up 10 million, then I needed to figure out how to actually put those 10 million into a database. And that was another challenge. And with Mongo, there was two specific ways. The first way was just thinking that I could loop through, create basically a 10 million loop and see the database that way. I quickly discovered that that would cause a lot of issues, including a memory leak issue. And so then looking more into Mongoose, Mongo, but specifically Mongoose in this case, and looking into the insert mini and being able to batch it out. So batch it out in terms of 10,000, 1,000, 10,000. And looking at it that way and then inserting those 10,000 in. Looking at it that way allowed for everything to be inserted, and I eventually was able to get it down to about 12 minutes on the insertion rate or insertion time for 10 million data points, which was nice, right? And then on the queries, so querying the database took about 0.4 seconds for one query, and you can expand that out. We did end up testing multiple different sizes, so how does it handle under one query, how does it handle under 5,000? How does it handle under 10,000? But for one, it was about 0.4 seconds, which, again, having no baseline, I thought was okay. Could always do better, definitely could be better. But I wanted to see then what SQL was like. So I set up Postgres and took a little bit of time to set that up. And then after setting that up, the question is what do we make our schema like for Postgres? So Postgres has the ability to actually insert into a table arrays, unlike MySQL. And it actually natively supports a JSON structure. And so that's really nice, but I also thought, okay, I'm going to need to do two tables. I had a data shape that kind of, there is an array of photos within one of mine. And so I thought that I would do it that way. But the photos that are in the array actually are not necessary to ever query on their own. If they were necessary to query on their own and just get those specific photos, I would of course want them in their own table so that I could grab them out individually and then just create a join table that would allow me to grab basically my other data, which is details for a description, and my photos and combine them together at a different point, but access them separately. But since I never was going to have to actually access the photos separately, I could just utilize the fact that Postgres handles arrays natively and insert those in. So this resulted in one table for Postgres, kind of feeling a little bit like Mongo, which we'll get to in a second. And so after being able to build this one table, fairly straightforward, I then was able to seed the database. And so using, in order to seed the database, again, that was kind of a twofold thing. I started with a library called PG. And again, it's kind of the same thing with Mongoose in terms of insert many. PG does not have the ability to insert multiple, so we ran into the same issue of a memory leak error. And so then looking into it, there's another library called PG Promise. And what PG Promise does is allow for this, well, it allows for a lot of things, native async and await, of course promises, but it also allows for the ability to insert multiple values into a column, into a database at one time. So again, able to see the database in 10,000, 1,000, 10,000s using Postgres, SQL, which was nice. And then myself, and then I looked at the time for that, and that was about 12 minutes also. Again, very similar to Mongo. So then I went on to test the queries. And in testing the queries, I looked at it and found that the queries were, for one, was 11 seconds. Consistent 11 seconds. Since there are no joins, since there is, I did vacuum vacuum the table, the table in order to reduce its size and clean it up after inserting 10 million. But even with that, still there was, at best it was 10, at worst it was around 12, but consistently 11 seconds. And that's for one. Once I started doing more than that, it became even longer, obviously. So the final verdict actually was to go with a Mongo database, a NoSQL database. It's easier in terms of the complexity because it's JSON based, so it's easier for most front end and back end programmers. And the querying itself is significantly faster. So what I need to do from here is to figure out why it was 11 seconds and see if that's an inherent part of querying a table that is 10 million. But more than likely what my major shift is going to be is now focusing on a Mongo database and really looking at optimizing that and working in the future with Redis and caching services in order to speed up monitoring more. But that was really kind of my most recent challenge and how I've kind of overcome those step by step. So hope you enjoy. Thanks so much.